Wait, the guard had a flag? What's the guard's flag? Please tell me I can just... Oh no, this is just a... Hi friends, welcome back to the channel. This is like the third day in the row that I haven't cleaned my office. Ignore this. If you're new here, my name's Ash, I'm 27, I'm a cybersecurity enthusiast, and on this channel we go over all things cybersecurity, hacking related, and we play capture the flags together. On today's video, we are going over day 10 of the Advent of Cyber 2022 event from TryHackMe. If you need anything else, timestamps, playlists, links will all be in the description. All right, let's get into the video. Okay, so we're on task 15, which is day 10, and this is hack a game. So the point of today is learning how data is stored in memory, like games and other apps. We're going to be using some simple tools to find and alter data in memory, and then we're going to explore the changes that happen from them. So the first section is memory of a program. So anytime executing a program or application, data is going to be processed through our RAM, random access memory. So in our case, we've got a video game that's got health, we've got the position of the character, movement, speed, direction. All these variables need to be tracked and easily, quickly accessible and get stored in our RAM. So the point here is we can modify the relevant positions of memory, which then tricks the program or the game that maybe we have more health or maybe more score, which is cheating. But so it sounds quite simple, but I guess it will find out that it's going to be more tricky is actually finding where in the memory that this sort of thing is saved. So we're going to be looking at some tools to help us actually navigate and find the memory that we can alter these variables through. Great, so let's start up our machine and get straight into it. So we'll just scroll up and hit Start Machine at the top. The next section is the Mighty Cetus. The Cetus is another application or a browser plugin that works with Firefox or Chrome. And this is going to allow us to easily explore memory space of a WebAssembly game that runs in our browser. So the point of it is to let us find the data in the RAM and also modify the game's compiled code and alters the behaviors that we want. So if you want to do this on a local VM, you can go ahead and do that. I'm going to just use the show split view in this case. Great, so now that's open and we're connected to our virtual machine via TryHackMe's network through VNC. The next section is accessing Cetus. So let's follow our instructions. We have a bookmark already here, so we can go and double click that to open up Chrome. So it looks like it's opening up 127. So that's the local host, that's this machine. So it's running the web server. Next up, we're opening the developer tools. So we'll go 3 dots, more tools, and developer tools, or Control-Shift-I. Now, just based on the size of my screen, I'm just gonna put the dock side at the bottom so we can still see the game a bit better. And now if we go to more tabs, we can see Cetus. Okay, so mine's opened up fine, but if you see a waiting on WebAssembly message, just hit reload or refresh. Next section is guess the guard's number. So we can click into our browser game and we can walk over to our, make sure to press space from that first message. And we use the arrow keys to go over to this guard space and we get a hey, you're not getting through this. So we're gonna ask. Okay, and this is the challenge. The guard's saying you need to guess a number and we have our number to input, which chances are we're not going to get it. So let's read our instructions and see how we can access it through the memory. So you can use Cetus to find all the memory addresses used by the game that match the given value. In this case, the guard's number is probably a regular integer, so choose I32 for 32-bit integer. So we've got that selected. Cetus also allows you to search for numbers with decimals, usually called floats, represented by F32 and F64 types. And for strings encoded in ASCII, UTF-8, or bytes, you need to specify the data type as part of your search because for your computer, the values 32 integer and 32.0 float are stored in different formats in memory. We will use the EQ comparison operator, which will search for memory addresses which content is equal to the value we input. Note that you can also search values using any of the other available operators. For reference, this is what other operators do. So find all contents that are equal, find all contents that are not equal, find all contents that are lower than a value, find all contents that are greater than a value, find all contents lower than or equal to, or then greater than or equal to. Okay, so these are like some basic operators that we would find in programming languages. So since the guard uses a random number, you will likely find the memory address of that first try. Ah, cool. Okay, so let's put in a try, like just a random number. And then they've given me a random number. So we can actually search this integer and EQ for exactly match I32, and then we can just hit search. Then down the bottom, that's giving us the address and the value. So this is all stored in hexadecimal. So the address must be the location, the value must be that integer itself. So we can just hit bookmark so we know where it is. And we have a helpful handy link that we can put in our hexadecimal to decimal. And by putting in that value, that's exactly the number. So out of interest, what shows up when we put in, okay, so that is the decimal address of where this variable is stored in RAM. I don't know what to do with this information, but it's fascinating. Well, actually, I guess now that we know the address, next time we come here, we can just search that address and then find the new value. I guess that's what we're gonna do. Okay, so let's talk to the guard again, but this time click over to our bookmarks and our value has changed. And now if we pop that into our converter, we'll have a new decimal number. So if we go through space, and now we can pop in the new number and hit enter, and we guess the random number. That's actually kind of sick. Next section, getting through the bridge. All right, so we're now looking at trying to get through these like snowballs. I guess we're going to change the speed or direction or something like that. So we're learning about differential search, which allows us to run successive searches in tandem, where each search will be scoped over the results of the last search, only of the whole memory space. Okay, so it's like one after the other sort of thing. So to help us better understand, suppose you want to find an address in memory, but you're not sure where of the exact value it contains, but you can, however, manipulate it somehow by doing some actions in the game. You could manipulate the value of the position of moving, for example. Instead of doing a direct search by value as before, you can use differential search to look for memory positions based on specific variations of value rather than the value itself. Oh, okay. So like if our speed is set to 0 because we're not moving, and then once we are moving, it sets to 5, so we can search for a variable that's going between 0 and 5, so that sort of thing. All right, let's go back to our search module. Yeah, it's funny now that I see value empty, differential search. Didn't notice that before. So if we just hit the search button, we get the same results. 548,753 is the total number of memory addresses mapped by the game. So we can run a second search of the LT operator, which was less than, lower than. So now by hitting search, we can just see 23 results, and we've left it empty. So these are all the ones that have changed. So these are ones that have decreased in value since the last search. You can of course continue to do successive searches. For example, if you now wanted to know which of the 44 results from the first search have increased the value, you could simply do another search with the GT operator with no value again. So we'll go select GT. Now we're down to 20. All right, so it's over us. With this information and knowledge we now have, what can we find? What can we change to get over this bridge? Okay, so I just died. I thought I was going to look for either the speed of the character or change the speed of the snowballs. But if we go through, we can get hit, and I don't think I can see there's a health indicator up the top. So that's actually the goal, is we want to find the health. So we can see that that's going down. So that's what we're after. We need to find the health, and then we need to figure out how to actually increase that health. Give us like infinite health, and we can just walk through. So to do that, let's do this search again, and we'll do it before. So nothing's changed. So I'm just gonna do it quickly again. So we'll start with the EQ, was it? And we're looking for integers. Okay, so that's everything. Then we go LT, less than. Now we get 38. Okay, so now we need to lower the health and then search again, because it would have lowered since that last point. So we can just sort of keep hitting search and then we're down to 1. So something keeps lowering. I don't know what it is. So let's get hurt. All right, then hit search again. And we've only got 1 result. Is that the right one? So if we threw this over into our hex, we do have a large decimal number. I mean, it could be stored in, you'd think it would just be like 0 to 100 or something. Oh, okay, one's standing out. So after searching it, getting hit, and then searching it again, I can see a value that's not stored in hexadecimal. It's just a decimal of 160. So that could be the one that we're after. So if I get hit again and then we search it, I feel like that was the right one. Maybe I should have bookmarked it. So testing that again, we see this same one. I'm assuming it was the same one. I'm gonna bookmark it this time. This time it's got 85. So that might be the damage it's taken. This one, get hit. I mean, it's definitely changing. And no, that's getting lower. I'm at 25, so this is definitely our health. So if I go freeze, can I just walk through without, okay, that's working. And now we get to the end. Our health isn't going down, so nothing is going to kill us, and we can just walk on by. All right, and we should be getting a flag or something. Wait, the guard had a flag? What's the guard's flag? Please tell me I can just, oh no, this is just a, all right, fine, I gotta type it out. All right, so we got that. How do I get the guard's flag? Let's go see if he'll give it to me. Otherwise, I gotta do it again. Hey guard, please give me that. Oh, there it is, cool. Awesome. All right, after manually typing in our flags, we've got it. That is day 10. That was really fun. I like the game element. Gamification is always good. Thank you very much for watching to this part of the video. I appreciate it. I hope you're enjoying this event and I hope you're enjoying the videos. I'm trying to do all 24 videos before the end of the month. So please leave a comment, leave a like, consider subscribing or dinging the bell if you can. It supports me, especially encouragement trying to get through all this. So I do appreciate that. Otherwise, I appreciate you and I will catch you in the next one. Oh, but just quickly, YouTube's got a video up there somewhere for you, and then also a playlist. So yeah, I'll leave that with you. Have a good one and I will catch you in the next one. See ya.